In this example, we're going to sketch a graph of the function 2 minus cosecant of 1/2 x plus pi for at least one period. I'm going to again apply the t-table method. I'm going to show one demonstration of how you can do this using the cosecant values of a t-table. First things first though, I'm going to take my original function there and I'm going to rewrite it so I factor out the effects of the period change. Meaning I'm going to rewrite the inside of the cosecant function as 1/2 times the quantity of x plus 2 pi. If you would like to go one step further and write it so that the vertical shift is after the function, by all means, you can then write this as negative cosecant of 1/2 x plus 2 pi plus 2. Either way though, from here we can work with a t-table in order to come up with x and y coordinates for this. The beginning of this t-table is just going to be like sine and cosine, where I'm going to begin with 0, pi halves pi, 3 pi halves, and 2 pi. After that, I plug in the values for cosecant. The values for cosecant are going to be just the same as the values for sine, except instead of 0, we have asymptotes. Sine would normally be 0, 1, 0, -1, and 0. So instead of 0, I have an asymptote, and then 1. Instead of 0, I have another asymptote, and then -1, and another asymptote at 2 pi. From here then, let's apply our changes. Starting with the y-coordinates, I will do the amplitude first. Always do the amplitude and the period change before you do shifts. The amplitude here, I don't see a number in front of the function of cosecant, but I do at least see a negative. The number in front of cosecant, just like a coefficient that you don't see, is a 1. So really this is multiplying by a -1, and that is what I will do to all of my values here for the amplitude. I will get -1 and +1 for the values that are actually numeric, but the asymptotes are not going to change. What I will do to denote that is just I will use an arrow all the way through. That way I don't need to write D and E every time because that's not going to change. After the amplitude, you do your vertical shift. Your vertical shift is the +2 that we have from the function. So we're going to add 2. That will give me 1 and 3 for those two values. Next, we have our adjustments on the x values. First thing you do for the x values is the period change. For the period change is the number that we had factored out of the inside expression, that 1/2. I'm not going to multiply by pi 1/2 though, I'm actually going to divide by 1/2. Which will give me 0, pi, 2 pi, 3 pi, and 4 pi, as dividing by 1/2 is equivalent to multiplying by 2. After that, we have your phase shift. The phase shift is the value on the inside after x. Because we have a +2 pi there, that actually means we're going to be moving to the left. So I will be subtracting each of my values by 2 pi. That will give me -2 pi, -pi, 0, pi, and 2 pi. I now have my x coordinates and my y coordinates. So let's create this graph. We move this over ever so slightly. There we go. I will draw my asymptotes first. I have asymptotes at -2 pi, at 0, and at 2 pi. So I have vertical asymptotes at each of those locations. -2 pi, 0, and 2 pi. I then also have coordinates at negative pi and positive 1. That would put me about here. And also at pi and positive 3 puts me about here. Now to connect this, keep in mind that we should not be crossing my asymptotes. When graphing cosecant and secant, keep in mind that they tend to look like these parabola type shapes. They are not parabolas because they do not go infinitely in the x direction, but they have these U type shapes that go in opposite directions. For example, cosecant typically looks like this, where you have U's go in opposite directions, and secant looks like this, again with U's in opposite directions. So when I look at these points and I know that they should be the peak and trough of the particular U's, if I try to think about what directions they're going, if I try to do this, this would be incorrect. The reason is because if you think about the range that I would now have then, it looks like all possibilities for the range are possible because I could get, say, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. There's somewhere on this curve where I could get any of these values. So that is not correct. These U's should be going in opposite directions, and more specifically, they are not going to cross over the baseline. Your baseline is at +2 based on our vertical shift. This should not cross over the baseline. So the U over here on the left should actually go down. And on the right, the U should actually go up. That way they do not cross over this baseline. That baseline would have originally been the x-axis, and cosecant and secant do not originally cross over the x-axis. So they likewise should not cross over the baseline or midline.